Hello everyone, welcome to another stream. How are we all doing? Hope we're all doing good. So yeah, guess it's open that terminal again because I forgot if I zoomed in or not. There we go. Hey there, Samaric. How you doing? Yeah, I just need to post that we're live actually. Let's do that. But yeah, so today's a good day because we're working on the final feature. The final feature of the GPU subsystem. Bum, 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 bum. So why, like, what is that feature? So last stream, what did we get? Yeah, so last stream we got this readback stuff done. So there's two different types of readback. So we can queue up a command which does a readback, and on the GPU, and then on the CPU you'll just do this readback start here. Wait, let's go to the prime example we've got. So effectively you queue up, as you're recording a command buffer, a readback command. And here we're reading back the logo texture. And then what you can do at the start of the next frame, you can do readback start, or not the next frame, 2 frames later. You can do readback start and you can essentially read back off of a queue. And we just read back our texture. But you can have multiple readbacks on the same queue. It's just a way of grouping readbacks together. But also there's another version of readback we did, which was, here it is. So we do it once. I might have to fix something. I remember now. Yeah, so we do this readback auto copy, and this one you can basically it will automatically copy it to a more persistent place in memory. Whereas if you were to read back and fetch it from in between the start and end, as soon as this frame has been recorded, this piece of memory where we look at the readback data for, is probably going to get overwritten by the GPU again. So what this auto copy does is it automatically does this part basically where it reads from the queue and copies it to more of a persistent piece of memory. Hey there, Not So Red, how you doing? Yeah, doing good, man. Doing good. Hope you're doing good. How's things your end? So what we're going to do today is do another type of readback, which allows you to read back a list of commands and command arguments that are produced by the GPU that the CPU can then get and then execute CPU side. So this would be very useful for debugging, but also potentially for some GPU driven stuff in the future. So that'd be good. So I wanted to double check quickly that figure this out. When we make this auto copy, I think we don't clear this auto copy entries back to 0 again. We don't, do we? It just keeps going around. Right. So there's like an auto copy queue ID. So at the start of the frame, we basically do this read queue for the auto copy queue, and we just basically take the entry and we just copy to the more persistent piece of memory from the readback buffer, right? That's all we do. So what we need to do at the end is just say, right, number of entries, can we clear those? Because it's just gonna keep copying it. If I comment that out, we can tell, right? We can check. Let's put a breakpoint in. Now this breakpoint should only be hit once, but it's going to be hit multiple times. So we run that in the not you, GF. No. Build game. Right, so we hit it here. Okay, hit continue. How did we crash? Oh no, it keeps running. Yeah, but that entries count doesn't get cleared. It's maybe, right. So I don't think the problem is reading when you read it back. I think the problem is more like when you like append to this array, or just keep appending to ones after, basically. That's all it'll do. Just run out of space. Oh well, that's not a big bug. That's good. Cool. So let's add this new readback buffer. You know what? Maybe we'll start from it's on a slightly different thing. Where's the more hard-coded ones? Yeah, so I think what I want to do is maybe let's make the upload buffer and readback buffer and the hprintf buffer. So, because remember we've got printing working, right? We got printf. Oh, I hit the breakpoint. So, yeah, because remember we got printf working, right? Days. From shaders. So we just want to make that really easy to do, because right now it's literally rocket science. You have to add it to the constants and manually set it every time into the constants that you upload to the shader. So notice here we've got this printf buffer that comes into the logo constants, and then you have to then yeah, which is a bit annoying. Like if you want to print from a shader, you just want to call a function and print, right? And that to automatically happen. So the first problem we've got to fix is that that we've got two upload buffers, two readback buffers, and two hprintf buffers, and we do that because we essentially double buffer. We switch between them each frame, right? One time the GPU reads or writes to it while the CPU is doing the opposite thing, right? So in the case of the upload buffer, the GPU will read from one frame while the CPU writes to and prepares the upload buffer for the next frame. So what we want to do is only have one of them. So this means we can use this index in the shader, right, and not have to sort of know what offset we are, or which one we are. And then I think in the back end, in the Vulkan backend, what we want to do is just simply overwrite that, because we already do that for the surface, right? So here for the surface, this is in frame start, I think, right here. So when we start a frame, we wait until we can actually use the resources and the GPU is finished with them. We require the next swap chain image. Then, after flushing some caches to do with the upload and readback buffers, we get the surface and poke the correct image handles in there. So we want to do the same thing for the upload. So you've got two upload buffers. There's two of those. So we can use the active frame index on that, I think it's called. There we go. So that will be that will switch between 0 and 1. Every frame will go to the other one, right? So that'll be buffer. Nice. Bear in mind, we've got to use the index for upload buffer. Then we want readback and then hprintf. So readback, then hprintf. Capitalize that and that. Oh, we missed some bits here. Upload, readback, and hprintf. There we go. So those are now going to be updated. We've now broken where we've referenced these things is all. So no biggie, we can just fix that. So what's this one doing? So maybe I didn't. Oh. Right. We need to update the descriptors and not. It doesn't really matter about the other things. We'll do it here anyway. So all of our descriptor updates live in some massive buffer that we've pre-allocated. It can be made smaller, but it just means we can just do a descriptor update with template, and it's just one function call. So it's pretty nice. So we can take this, and where we just were, or just was, so we want to do like, we want to poke these things. So we're going to say this one is equal to, active frame index, active frame, active frame. So we're poking the descriptors. So next time we call update, which is just down here, where is it? Oh, come on. Oh, we do update after bind, isn't it? Let's search for template. Here you go. Oh, it's right underneath it, don't worry. Yeah, so this is our update descriptors. So we just give it this template memory, and it will just update all our descriptors for the shaders so they can have an updated version of those. So excellent. Okay. So now what we want to be able to do is refer to this in the shader. So really this thing here needs to be shareable with shaders. Like, so we can reference these guys and have a function to do so. Hey there, glorious sir, how you doing? How's things been? Hope you're doing well. So what we want to be able to do effectively is say upload buffer, maybe read or readback buffer write or something like this, and then hprintf. Yeah. So we need to define. So let's go to our like project. So we've got the GPU abstraction, right? And we've got our graphics abstraction, which uses the GPU abstraction to actually do graphics. So this is like making this GPU is our own graphics API, right? So it like replaces OpenGL in a way, right? So this to-do needs to get destroyed soon. A way to upload buffers and textures, update. You already done that. We just need to do this pull allocator stuff. That's fine. But yeah. So what I'm thinking about doing is we need a header file which can probably be called GPU shared maybe, and we might need a GPU shader. I don't know. So this public header, how's it going, Glass? Imagine didn't see when your flawless language is like PHP, yes, flawless. Can I ask you my age? I'm 28. 28. Thank you, appreciate it, Rick. 76. Yeah, it's good. Like, yeah, it's not like a full-on C compiler, right? It doesn't go all the way to assembly or anything, but you know, it goes most of the way there. But yeah, I did read the whole language thing, the whole tokenizer, syntax tree, all that from scratch. But yeah, I didn't quite go the full way down to some form of assembly. Quite close though. I've got my own like optimizer, but I've got like very little optimizations. Maybe, yeah, I've got like no optimizations at the moment. But yeah, but it's ready to have some optimizations. But also, I don't need to optimize it because SpearV has an optimization package you can just take use of, so it's good. Actually, things are kind of fishy for me right now. I might have to be forced to relocate to another country. Wow. Ooh, well, yeah, so just a lot of, you know, you change your whole life really. That's crazy. Is it for like work purposes or just, or is it like visas, stuff like that? Hey, the Glass, SQL injection is actually a feature. Okay. Okay. No, I'm 28. Yeah. Using a Boomer slash Gen X language. Exactly. Exactly. Gen Z uses Gen X language. Shared.h. We need a shared thing between the CPUs and the GPUs. Just get one of the you always got to remember this, right? Always put your pragma once at the top if it's a header file. Never forget. It's so easy to forget. So I want this to be shared, right? Between the CPUs and GPUs. Cool. Hey, Underclosure, how you doing? Yeah, project's going good. And hey there, Davros, good to see you. Yeah, so we've got right. To give a quick recap, we have basically been spending the first 8 days getting the initial project structure together and our initial graphics or GPU API with testing some shaders and getting HCC in here. We've got support for making our own buffers and textures. We've got support for uploading to a resource, which we've tested with one of our logos, reading back with a Readback API. So we've got a Readback API which allows you to read back at a very specific point in time in the frame, or we've got one which automatically copies it to more of a, it's an extra copy, but it copies it to more of a persistent place in memory. We've got an API for launching compute shaders and synchronizing on resources, so we don't get any reads and writes that happen at the same time across different shaders. So yeah, it's got a basic GPU API, and we're working on the final feature today. And when we have the final feature, we'll be going more back into the engine and getting stuff like custom memory allocation sorted out, and probably doing a cleanup pass on the GPU code after that, because we have lots of very temporary arrays, like just, you know, arrays that like got 32 like entries for some reason, right? So yeah, this is the state of the project so far, but it's going well. Yeah, and then after we've done more of some core engine bits, we'll move on to doing some custom UI, so we can tweak some values while we're in the game. So I can give it a run. You can see what it looks like. So we also have printf working from a shader, so we can print from shaders to the terminal. Here's the logo that we load from disk. There's 3 compute shaders going on. There's a background compute shader. There's a compute shader which renders a triangle for some reason, which we're not going to be using triangles, but it renders a triangle because Perry wanted a triangle. And we spent, and on that stream we found a bug, and I had to fix that bug. Sorry, I found a bug in the compiler, and we had to fix that bug, all because Perry wanted a triangle. But it's good. We fixed the bug, and then I rendered a logo. Yeah, so there's 3 compute shaders. Bam. How do you like KDE? KDE is great. It's pretty stable. It's got decent features. You can tweak it. Yeah, just gets out of the way and allows me to do stuff. Here's me, Gen X, using Rust. It might stop me turning into a boomer. Oh, gotcha. Yeah. Oh, Toad Beaver. Aren't you funny? Hey there, Valor, welcome. How you doing? So, we want to make it super easy from the shaders. From the shaders. Wait. GPU shared. Oh yeah. We're gonna make it super easy to use a readback buffer or an upload buffer from the shader, so we can just write directly into it and the CPU can pick it up, right? Or the hprintf buffer as well. So this can maybe be shared. Maybe we can have one called GPU shader, and it's got some, there's too many files. Why am I making all these files? I don't like this. There's just files everywhere. I've got files in my files. Shared, and then I can have shader, but then they are so similar to type. Or I could just have if-defs. If-defs might be the way. If-def HCC and if HCC. Oh yeah. So what I want to do in here is define a few functions, right? I want to have a super lovely maybe goes in here. Let's just put it in here. So I want to have a function that allows me to, you know, maybe I need a GPU shader as well. You know what? We're making another file. I don't like this. This annoys me, but we're doing it. Oh, there's too many files. It's so much easier when you only have one file, right? So great when your project is just a single file. All right. So this one is only included inside shader code. So we can put an if-def around that. Error. This header is meant for shader code only. Yeah. And then the lint is just going to be complaining all the time. But anyway. So what we want is a function which can probably we want a function that can allow you to write into, so we might be able to say GPU, maybe static inline, GPU upload. Or maybe just make it define. I don't know. GPU upload. Like, something like this. So you're gonna read from some form of like offset. And you want to read, maybe you might have like a read float 32. Let's have a look. And a way to do this in the HCC code, third party HCC, lib HCC intrinsics. Yeah, these guys. Effectively, it's going to be a wrapper around these. Ways to read from these byte buffers. Hey there, Alparkin, how you doing? Good to see you. Hey there, Koi Coder. Not just visa problems. I'm just got so, I've got not so bad country does not require visas nearby, but getting a job is going to be rough since I've got no real job experience. Just got a bachelor's degree. I was going to do masters, but government want me to do other things. Huh. Right, I see. Yeah. Yeah, it's difficult to land that first job. It's like so difficult, but yeah, have you got any things you've been working on the side that you can sort of help, you know, got any small little side projects you've done that are key to the thing you want to apply for? Hey Nico, how we doing? How you doing? Oh, cool. How did the interview go, Ty Beaver? Yeah. CPPs. Right. So we want to be able to read or load. Like, we could basically like do a define. Now, so we could do a define and say like load upload buffer, right. Right, so call a macro, let's do it. So what we need to do is say, right, go to start. So I want to copy that, pass in the byte index, nothing else, and then that'll go there. And then we want to use that, we want to cast into this from that GPU resource index upload buffer, right? And then the byte index goes in there and go down to here, and then we just do 11 of those, please. There we go. So now we've got some convenience functions which can help us. We'll call this upload buffer actually. That allow us to load from our upload buffer at a byte index in the compute shader. If it's not like, because we've got three different types of uploads, right? We've got the ability to upload directly to a buffer at some offset and size, and the copy will happen automatically at the start of a frame. We've got upload texture, same thing, right? At the start of a frame, it gets copied. After we write to this void pointer from the CPU, of course. And we've got upload manual, which allows us to read from the upload buffer directly in the shader. So this is what this is here, is it's a convenience way to achieve that. We're going to read from it as a byte buffer, right? So it's just a buffer of 4-byte words, and we can pull out different 4-byte variants, right? U32, S32, F32, or vectors of those, right? So that's nice. The next one is store. So we need to be able to store, let's do this again. So we want to say store readback. So obviously readback supports the other way, right? And we want to store the value. So this one is going to be a write only. And we're going to be doing read big. How do we get the value in there again? Oh wait, yeah, it just goes in there as an argument. That's good. Right, back to here, good. And we'll have 11 of those. Ta-da! Right, so there's our convenience functions for storing into the readback buffer. And there is there one more? Oh, hprintf. So we've already got defined for that. It's called hprintf. It's actually in the file I just closed. So there's a super lovely macro which does it does the printing for us. So we just want a convenience function which does this. Now hprintf is already taken, which is a bit annoying. So what else can we call it? I could call it GPU hprintf. But then like these should probably be called GPU that, right? So we should probably think about that as well. So we want the format and then the variable args. And that's just going to be hprintf. Write only buffer for me, please. Wait, U32 buffer? Probably. Right, write a U32 buffer, please. And then I want to have the format and then the variable args. Yep. So that would be super nice. So now we've got a shorthand way of doing that from any shader. We can just do that and voila. Hey there, Perry boy. How you doing? I was just telling everybody about your that triangle you told me to do and how it derailed it derailed the stream and made me fix a bug in the compiler, which was a good thing. Remember this triangle, Perry? It's a good triangle. Perhaps we should keep it in the game. Yeah. Perhaps we should keep it there for for all the memory, you know? Maybe you can press a secret button and it just prints out this triangle on the screen. There's a secret key combo, you know? It'll be good. It's Virginia Precision. Cool. I hope you get it, Ty Beaver. I'm trying to not catch on fire in this heat in here. Also I'm waiting for a fresh GCC to finish building. Other than that, doing fine. Nice. Why are you building a new GCC? Did you port something to FreeBSD, Nico? Yeah, it is a bit warm today. It's actually a warmer day today than it has been the past few days here too. Oh wait, do you have resources on this? Using continue tooling or what to build? Oh, interesting. Most of this some junky C++ game prototypes, but trying to work on more serious 2D top-down RPG style. Yeah, for the last time it was productivity super low as it's more very fast here, basically nothing potential prior. Okay, that's cool. No worries. Yeah. But yeah, if you want to like speak about it, just open up a message in Discord or something if you ever fancy chatting about it. I'm building GCC from source because I need adder, which is not in ports, except for ancient GCC 6. Ada. I think I've seen adder before, but I've never like. Huh. What projects use Ada that you need to compile? Is it something for uni or? I have no idea. Rightio. So, you know, why don't we say, you know what, I've got an idea. Why don't we do this? GPE, readback, store. This is so counter, you know what I mean? Because we're saying like GPU upload, load. But anyway, that's fine. Good. So GPU shared probably wants to include core. Oh, I don't have a core shared yet. That needs to get reworked. Excellent. So I'm hoping that we can get rid of these U32s at some point. Probably works. Oh yeah. Right. So let's see if we can rework this, right? This is going to be amazing. So this hprintf buffer, no longer do we need it. Maybe we need a way to... Right, let's just do placeholder. Okay, so we need to be able to say HCC write only buffer U32 hprintf buffer. So this is going to be equal to GPU resource index hprintf buffer. So we can just do that. Now, and then we can set up. So at the start of the frame, we have a frame initialized compute shader which just runs, you know, it launches like one of these, but then for all of the threads which are not the first one, so it launches one group, and for all the threads in that group which are not the first one, it just returns, and then the single thread sets this up. So yeah. So we might need to do, yeah, when we do the readback buffer we was about to do, we'll need to add something here as well. But anyway, it's good. So where's the other hprintf buffer stuff? So here we're going to replace this, right, with that super lovely GPU prefix. Let's see how well that works. Right, didn't compile, so we've got to do, what? What have you done? Oh, I didn't include shader. So the shed probably wants to be included in, yeah, the head, that's good. Now this one wants shader. Include GPU right, this one's failing for some reason. What's the error saying? Expanded macro. I think it's undeclared. It's not declared. Oh, casting. We've got to wrap that in a in brackets there, haven't we? Right, so should we let's go in there and make that change. So in the hprintf stuff we're using buffer here. This should be wrapped in brackets, right? Because macros. Too many brackets. All the brackets. There you go. So, you know, I could do something like this instead. Write only buffer uint32t. And then we want to say, let's call it underscore b, I guess. And then you can just say underscore b the rest of the way. Very nice. What? Oh, I didn't put a backslash there. Cannot cast signed in into a... Okay. It's a signed int now, is it? Right. So I guess all of these things here needs to be casted into a U32 first. It's just something in my compiler where it can't... It's got to be a U32 for some reason, and Sign32 doesn't like it. I guess we can... I don't know, I can make that better in the future. Unhandled constant data type. Constant data type, what? Ooh, I've not handled constants which are resources yet in the compiler. Right, there's a few things got to fix. So we're going to take this with us. We're going to place that in the HCC library. Sorry. HCC lib HCC intrinsics. What else we saw now? HTC. There we go. So we just want to update this in the HTC code base. There we go. And then we also want to fix another thing, which we want. So in our SpearV side of things, we've got constant type, which is a resource. And we're not generating the correct SpearV constant for this. So we just need to hop into there. Source SpearV. So constant deduplicate. And apparently in here, we're not handling it properly. So what is it? It's a resource, right? So a resource is basically, where's the integer ones? Is it here on me? So if it's a buffer or a texture, it's basically a U32. So I'm pretty sure I've handled that right. I don't know. Yeah, I think I've handled it fine. So we just want to say if this thing is a resource, then like a resource constant, what we want to do is get the resource, so we don't care about the type. We just want to output a constant, which is like the U32 one. So you get yourself some words. So you want three words. I don't need those words. So it's this line here. Operands 2 is equal to the constant data that we can pull out. And then 0 and 1 are set outside of this. This could be the fix. I don't know though. So I guess we can give it a bit of a test. Right, so let's hop into the HCCs and let's give the build script a run. So it seems to compile everything fine still in the test examples that we have there. So we're just going to open up a new window. We're going to go into HCC. We're going to get the not samples. We're going to grab the executable, go to third-party folder where we store our version of HCC. I just realized some of the Windows stuff needed a new version of HCC, but not gone and done it. This is not good. I need to go and fix the Windows build. So let's try and run it. So we don't recompile it. Excellent. So apparently it recompiled further now than it did before. So that's good. No member named hprintf buffer. Okay. So into our shaders. Oh, no. So our shaders compiled just fine. No errors. So now after we compile our shaders in the build script, we compile the actual game. So now we don't have hprintf buffer as these parameters to our shaders, right? We don't have constants that are taking the buffer now, because we can directly, using this new lovely sort of like standard library that we have for all of our shaders, we have ways to just printf directly using this index here, this hard-coded index for the resource. So it still don't work. So what's the constant? That's a good question. What is the constant? So we can dig through the SPIV code and see what that is. So how do we tell what that is? So I don't reckon. So we could build. So all right, where is it? Okay, I think we'll So the way we're going to look at this is we're just going to print it out, right? So we can just say like, found resource constant, right? So that'll print out in our build script. We just got to go ahead and recompile the shader compiler. Gonna grab our updated executable. I should make a script for this, just to do that automatically for us. But anyway, so now in here, if we rebuild the game, we found a constant 2 and a 3. So that seems like it's working, right? In terms of, it feels like that's right. Because if we go into here, 0, 1, 2, and 3. Why are we getting a 2 though? Are we referencing a 2? I don't think that's right. Could this be wrong? Zero, 1, 2, 3, right? We should be seeing 2 3s. Oh, no. We shouldn't be seeing 1, 3 because it's a deduplicated constant. So why are we seeing a 2, right? Can we search for this across the code base? So it's going in all of these, right? Which makes sense. We don't, like, there is an enum, right? There's an enumeration, but it's not being referenced anywhere from what I know. Readback store. We don't do a readback store anywhere. So yeah, that's a bit confusing. Like if I were to let's have a bit of fun. Let's add 1 to this. Now it says 4. Right? So now it says we found a 2 and a 4, which basically leads to the fact that this one here is the 3, but then the one that we have in the am I doing something super silly? We are using readback in the printf. We're putting the hprintf stuff into the readback buffer, like a silly bugger, Now I've only found a 3. Cool, nice debug in there. So we can now remove that. Crap, wrong chat. Okay. Ah, tired beaver. You should stop being so tired. We'll save your life. one day. Cool. So does it work? There we go. So printing still works, and we've removed that. The fact of having to explicitly pass in this print f buffer into a specific shader. Now we can just use in any shader. So this is super useful. So we'll also be able to read back as well. That's super nice. Right. This is good. So, right. What else do we want to do? Okay. Git status. Should we compile that properly? Right, let's do a release build so we get faster compilations. And then I want to check this in. There you go. Then I want to check this in. And then we can make a start on that readback command buffer. Does it compile? Let's have a bit of a go. Still compiles, still runs. Nice. So doing that git status again, we've added some couple of things, changed. Yeah, so we've add doc, git commit, stash a. Right. So we have added the ability to add the ability to directly use built-in resources, built-in GP resources, or GP built-in resources, that's it, direct in shaders without passing them in. Excellent. So that's a good commit. Okay. So the next thing I want to work on is a new type of readback buffer. So I think I want to add 2 more readback buffers, and you'll see why. There's a readback command buffer and a readback debug command buffer, I think. Something like that. Let's think about this. Come on. Yeah, maybe debug command. Yeah, let's do that. That's good. So the reason why I'm going to have 2 is because one is going to be for the actual game code. So if the GPU sort of decides it would be a good idea for the CPU to go and do something, it can append it to this buffer and the CPU just read it and do stuff. And a debug one will be there, so it'd be useful to like maybe have a separate one that can be used for debugging that we don't care if it overflows, right? So if we overflow this buffer, it's a problem. But if we overflow this one, it's not a problem because it's just debugging, right? And I think that's me the idea with these guys. So let's have a bit of a look around and I know you shouldn't really want these anymore. Yeah, I don't know if you already want these specifically anymore. You shouldn't want to reference these. Just get the surface, I reckon. Rust enums? What about them? You mean tagged unions? Because that's what they are. It's so weird in Rust that they're basically an enum is a enumeration or it's a tagged union. It's so weird. You would kind of expect a union to be a union or a tagged union, you know. But anyway, Rust. It's great, honestly. Okay. I'm not sure what's great about tagged unions. Because, like, in Rust, you have to match them all the time. Yeah, I know, but like, if you like, Rust has a union construct now. It has a raw union. You can do raw unions. Um, yeah, I don't know. Like, making that being a tagged union makes more sense. It's just weird. Hey there, Klopp. Klopp. Let's just call you Klopp. How you doing? Can I elaborate on the point of them being matchable? So the problem is the fact is you have to match them all the time. In C, when you have it all unsafe, and it's just a union and you have a tag field, you can just use it however you like, right? So here's this copy thing, right? This host copy entry. I know based on this res ID, I can just look up and I can just be like, is it a buffer or is it a texture? I can do that. And then I can just read this however I like. I don't have to match this and like I can just get in there and use it. Whereas in Rust, a lot of the time, if you have these tagged unions, you always have like you'll want to like you'll know it's just a buffer. So for some reason, you'll know, and you will have to create a function that matches on whether it's a buffer or a texture just to extract the type out sometimes, because you might have multiple, maybe you have multiple of these where and yeah, it's just a pain. Like in C, they're just super flexible. It's good to hear, Klopp. Yeah, doing good, man, doing good. We just landed the ability to use resources now in our shaders, um, without like the built-in ones without passing them in explicitly to the shader, so we can use our printf buffer and our upload and readback buffers without a problem. So it's good. I'm not sure you're talking about type beaver. I used it like before using your nappies, my friend. Like I I know how capable Rust is. Like using the match statement, they have to use the match statement to get access to your things inside. And if you share, like in C, like you might want to, like how you want to access this union. It could be dependent on other factors. It's hard to explain. But yeah, like having free will just to access this union is far better than having to like painfully match on it explicitly every time, basically. Yeah, in a Rust discussion. But yeah, it's like whenever you use those enums, you have to write a lot of match statements, whereas in C you just don't have to do that. But yeah, that's it basically. Yeah, well, I can't really have a concrete example because yeah, it'd just be effort to do it, you know. Um, yeah, I think that's one of the things is common fields you want to share between multiple variants, or you might have a structure which is used in multiple like a single field that's used in multiple of the variants. Yeah, but not all of them. Yeah, and you have to match. Yeah, I just have someone's roster. I don't want to tell you exactly. Yeah. Uh, um. So where were we at? What were we doing? We're adding new readback command buffers, aren't we? These guys. These guys. So how do we want this API to look? So the GPU is going to produce this solely, and we're just going to be reading it back. So it could be part of the whole readback loop. It could be a special queue ID where you would just get readbacks. Yeah, it should be its own API. That's what it should be. Did the music stop? How dare it? Right, so readback command buffer. So the basic API is going to be like, you know, it's just going to be an iterator. So you're just going to say readback command. So there'll also be a debug command one. So if you want to access a field that is in multiple variants via reference, it turns out it's to be possible because they match with OR patterns. They match A or B, and then bind parts of the patterns as variables. Right. So you have like a case, and you will have two variants with different things, and you do the pattern, right? I see that. And then I guess you can get the reference out. But yeah, and then you'll stick that in a function basically. But yeah, then you have to stick that in a function somewhere because you want to like do that quite often. I'll copy the code somewhere. Yeah, or variant B. Yeah, yeah, yeah. Do your thing there. Yeah, yeah. But then you're also tired. Hmm. But yeah, like it's very rigid though. You know what I mean? You're tied to that tag being that one of those specific tags. Like it's just far more flexible when you get to define it this way and be more like Yeah, I don't know. But I think often you typically, if you write those match statements, you'll typically put that into a function somewhere. Right, so GPU readback command. So we want to have a structure, right? So this is GPU readback command entry, I think we'll call it. So we'll be iterating and getting these entries, right? So you can imagine, so there's going to be a shared, in this GPU shared thing, we'll have some form of like, well, probably U32, right? It's got to be 4 bytes because it's going into those readback buffers, which have like made up of 4-byte words. So we'll have this GPU readback command type, and then we probably won't have any built-in ones. Yeah, we won't have any built-in ones. Yeah, type a command. Does it matter? Yeah, and then I guess the arguments, right? So you have like args, and you'll probably pull out like an args count, right? So maybe we store the type, the args count, and then the args perhaps, because maybe the the command can have a variable number of arguments, you know. So that'd be interesting. So we want to be able to say something like command read. Right, let's just keep the consistency here. Yeah. I don't know, I think it's a bit too like rigid, and you know, it's too like rigid for my liking, but you know. But I think it's good to have the tagged unions though. I think it's good to have it in the language. I just don't think it should be the only thing, right? I think more these sort of raw unions are yeah, are really good basically. Yeah, you have the union keyword nowadays. But that's all unsafe, isn't it? So when we want to read, I think, wait, what do we need to do? Yeah, we just need to have the entry, right? So just get the entry out. Excellent. So that's just an iterator, right? Doesn't have to be some C++ iterator. It can just be a while loop around a function, and easy, right? So we're also going to have a debug command read. Now, when I said this command one, if this overflows, it's a problem, right? We don't like it's problematic, and we probably want to handle that in some way. Like we definitely don't want the GPU to like overproduce. Produce these. You know what? I think we'll leave that out. I think that's trying to solve a problem that we don't have yet. Yeah, for now let's just focus on having these two separate ones. Okay, so this is going to be the API. And we're just going to hop into the GPU. Right, GPU.c, please. Right, what we're looking for. Excellent. So, we'll figure that one out in a bit. So I think we want to hop into the So I think we'll, yeah, maybe we'll have to call these in the same way that we have to call the readback. It has to be in between these starts and ends, right? So maybe this one. It's C++ when you have a union, you have the same issue. If you access union wrong, it might mess up the object model. Right, all that, yeah. Yeah, so unless you're using those, pod types, it's plain old data types, isn't it? Yeah. Yeah, everything should just be plain old data. So yeah, we want to call it in this readback start and end, I think. Then we'll process the commands in there. It's a good place. So how did that one work in the previous one? So we get access to this thing called a readback buffer, and then you get access to the queue, and you go over all the cursor entries, right? So for us, I think we're just gonna have a cursor into the read, right? Let's find this. So this could go up here with this one. Nah, it's fine. Okay. So is this decent enough for us? I don't think it is. So we need another one. So we're gonna have one for reading back commands. So just copy paste this. Do we call it readback command? Yeah, readback command buffer. So we're not gonna have a queue because it's just gonna be one queue that we read off of. Not gonna have any auto copy stuff because it's just gonna get processed there and then. Readback command buffer. As soon as there's destructors, not fun. Yeah. Yep. Enum/match is definitely a Rust highlight, especially pin expression. Yeah, I think the expression stuff is cool. Like if you can have like a match or a switch statement with expressions, or if statements. Yeah, super nice. I like that about it. It's just the rigidness of it, I think, is not to my liking. So we want to have the mapped memory, right? We're going to have a cursor that we read back through, and we're not going to have a queue. What we're going to have is those copy entries. We're not doing that. Oh, so yeah, all we need is the cursor and the mapped memory, really, isn't it? That's all we need. That's all we need, and we probably just want to. I guess that's it. So we need two of these. Read back command buffers. So one for the CPU to read from while the GPU is writing to the other one. And then what we want to do is probably nah, the bot seems to think PHP is not popular enough to care, you know. I tried to make a game from scratch, but I had to do a lot of planning on pen and paper. The fact you can just kind of get everything is insane. Yeah, it's because I've already thought about these problems before, and I've already done a load of Vulkan and just thrown it away. You know, and I really sort of understand the problem enough so I can simplify it. There are going to get to times where we're going to have to do like research, especially when it comes to figuring out what this game actually is. But yeah, it's going to, and off stream I do think about things. I don't just come here and without thinking and work. Sometimes I have to think about things in advance and be like, well, if I did that, then So yeah. The best type of advancement in programming typically comes from when you're away from the computer and you're doing other things and your brain has time to sort of like pause what you've actually done that day and sort of like make sense of it all, and then feed you back answers, right? Awesome. So I want to get this readback command buffer. So I think we just want to say that's the address of ggpu readback command buffers. My IntelliSense ain't working just yet because I saved the file. So I want to get the active frame. So you just get back your command buffer, right, something like that. And so there'll be a cursor. And so we could probably store the number of, what might be best is we store the number of, like it's just an array of U32, right? So we could map it. Like where's the mapped pointer again? There's just too much stuff open. So this is just an array of, this mapped memory is just an array of U32, right? There's no to do on that. So what you're going to be doing is saying command buffer mapped memory, then using command buffer cursor, and that. So are we storing the type in there first, or are we storing the number of? So we probably want to read. We probably want to read in like, hey, what is the, where is the end of this thing, right? There's a count. So I reckon we want to say like, hey, if command buffer cursor is greater than or equal to the command buffer count, I guess, then we could call that word count, but I don't know. That'll do. So that'll just return false there. And then from here, we know there's a command now. So I think we can store the type in there, then we store the number of args, and then we'll store the arguments after that, right? So we'll fish out the command. So we'll say entry out type is equal to whatever that is. Then we increment this thing by 1. Oh, what am I doing? Then we want to read the next thing, which would be the number of arguments. So we'll fish this out as a little local. Args count. So we need to fish that out into a lovely little local. And then we advance the count by what time I had less time you spend debugging? Yeah, I guess. It depends, right? Because you could plan something ahead which is very complex, and you think you're being, super clever and smart about it, you plan ahead about all this complication, and then you go and make the complication, and you've just made a debugging nightmare. So yeah, it's really, you've got to be careful what you actually build. Oh no. uh, what is this link, Nico? Let's take a look at it. Oh, another previous. Oh my days. Spicy. I take no position on what lands imports, but wants to make public comment. I doubt you read the following sentence. Zig is more. Oh, I remember reading this before. Oh boy. Zig is a general purpose programming language and toolchain for the maintaining robust, optimal, and reliable software. I'm sure CSH and PHP aspire to do the same thing. Ooh, spicy take. Oh my days. Oh my, I remember reading this one before actually. Yeah, this is a good read. But yeah, programming languages, everybody. Spicy topic. Thank you, Nico. It's really great. The people who work on kernels obviously have the most spiciest, or work in operating systems have the most that takes the most spiciest. It's great. Yeah, so we increment the cursor probably by Rs count plus 1, right? Because no, because you want to add 1 to the cursor, then you want to say, right, my then I want to say my args is equal to whatever it is at here. And then you add the args counter, and then you'll be at the head of the next command, right? To process in the next iteration loop. And voila. So that's for the debugging one. Now, obviously, I implemented that for the wrong one, right? So we just need to copy paste that. Debug command buffers, rightio. Copy paste all of this. Share it, no need to share code really. Just make sure we've got to get this bit right. Ta-da! Right. Oh wait, no, this one is the debug one. There we go. Nice. So yeah, command buffers. This is the high level code for it. We now need to do the low level plumbing. Bearing in mind, we probably want to reset the cursor at the frame start, right? So when you start, I'm not quite sure. Is it a frame submit or frame start? We just got to have a look. So yeah, yeah, it's here. Okay. So what we need to do is like, based on the active frame, is that right? Yes. Right. So we need to set, so firstly, let's get this active frame thing out of the way. U32 active frame index. Yeah, you can't really plan for stuff you have no experience with. Yep, that's right. You should, if you don't have any experience in something, you should just build the most terrible thing you can, and learn from your mistakes. Well, not okay. Build the best thing you can possibly, but it will be the most terrible thing you've ever built, right? With it. And you got to build stuff like 3 or 4 times, depending on the complexity, right? And then you can then you can start planning. What are your thoughts on leak code? I'm not sure what leak code is. Cursor. Bear in mind, this has got to be one of those command buffers, right? You set the cursor to 0, and then this one is going to say debug command buffer. Bam. All right, super good. So that resets the cursor, and we also at the start need to know how big is everything, right? Oh, what is this doing? Why is that setting the readback reactive frame? The queues, clearing the queues. Readback queues for what? Couldn't that just be done up here? I wonder if this could just be done up here, because they're only fired in the next. Yes, they can. Let's move them up here because it makes more sense. Set them all together. Cool. I like that. Active frame index, voila, there you go. So, okay. So what else are we missing? So we also want to fetch. So after we've done this frame start, we also want to read out into these guys the count, right? So to do that, you know, it's as if we need to sort of do like a command buffer. We need to do this. Readback command buffer cursor. Now this is going to be equal to 2, right? Which we'll make into some proper constant in just a second. But then we want to make sure that we read out into count what is it, the mapped piece of memory, right? So mapped memory. So 0. So a bit like how we've done with the printf buffer. In 0 is going to be the count, and 1 is going to be the capacity of the buffer, right? So this is going to be how much was written to you by the GPU last frame. And we'll read this one out. So we need some constants, right? Where do these constants go? So this has to go in maybe more of a shared place. So we've now got this new GPU shared thing. So we need to put those constants that we have in the internal. Where are those? They're here, right? Oh, these megabyte things. Right, I think I want to get this core. Oh, days. Source core. Where's the MBs? Excellent. Let's move these into the shared. E-source shared between the CPU and the GPUs. So now we can have these. So we've got upload buffer, readback buffer, readback command buffer, readback debug command buffer. We just put them at 8 megabytes. Tweak them later on, right? No biggie. So all we want to do is say, oh wait, we missed something. Yeah, so in HCC shader, there's these, for our printf buffer, we've got 0 being the cursor index and 1 being the capacity. So we also want to take these as well and store them inside that GPU shader was shared, right? Excellent. So we want to get some form of like command GPU readback command buffer. So that's where our cursor is going to be, right? The cursor of the command buffer is atomically incremented by the shaders to get the insert index, right? Command buffer is fetched to avoid overflow, and then the cursor starts at 2 because 0 and 1 are used for cursor and capacity respectively. So these are the numbers we need to use inside the source code here. So this is going to be the cursor index. We read back the cursor, which represents the end, and then the cursor starts on that one. Then you need to repeat this code, and you need to chuck the word debug at the beginning. So you do it for the debug buffers as well. And there you go. Cool. So, right, is that everything that we need to do at the high level? So we still need to, at the start of the frame, we still need to make sure we reset these to 0. Now, because it's a readback buffer, the CPU is not really supposed to be writing into these. So it'll be better if the GPU does this. So luckily, we already have this because we already have a type of command buffer. That's the printf buffer, right? And we have this frame initialize compute shader, which just runs once. So one thread does all this. So I've got this to do here, use shared constant. Guess what? We've just done that. So we just need to say GPU h printf buffer capacity. There you go. So it stores that in the second word. Okay. So doing the same thing for the readback command buffer. Readback command buffer, and we're just going to be storing those in here. So this needs to be GPU readback command buffer cursor index, then capacity index, and then we want to make sure we do cursor start, isn't it? And GPU readback command capacity. No. It's called cap, isn't it? Perfect. Right. So we just want to copy that one more time and do the same for the debug one as well. So let's just quickly sort these ones out here. So debug and debug. The rest are just the same. Okay. So this is going to clear it to, it's going to reset it at the beginning of every frame on the GPU. So every shader can now just use this and potentially write a command back to the CPU so we can process that, right? So I think this is everything at the high level now, right? We have the ability to store into these things. Well, we haven't written them in the... Well, there's still another thing to do, just as you think you've finished. So we need to put in to this shader thing. We need a way to write a command in there. So maybe so the thing is yeah, so we don't know what the the GFX, like the graphics part, is how it's going to use this, right? So we might just provide a way of storing. Yeah, we'll just say like readback command push, and all you're going to do is say, right, I want to push, like, I want to push this type on and this many arguments, and then we'll do that here, a bit like how the hprintf works, right? So we'll atomically add, if it works, we'll give back an index that you can write to. Now the problem is, what happens if it's overflown? So I guess we'll yeah, I don't know, unless we can do it a different way where we say push 3 args, 2 args, and that sort of thing, perhaps. I don't know. I would say figure out the problem you're trying to solve, and less stuff you have to figure out at develop time. Yeah, that's true. Yep. 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 Yeah, like a lot of the time, if you're midway through developing something and you have to design, it's just better if you just step away from the computer and just walk around in physical space and just have a think. Just sort of like just if you let the ideas come to you, and maybe you do some research and see how other people have done it, but just sometimes sitting down at the computer is not the best way to actually design something. LeetCode is a website for people to submit code solutions, code interviews, solve problems, just to rank performance solutions, however performance measured by precisely. Right, I see. Yeah, I don't know. I think, if you enjoy that LeetCode thing, that's great. I think that sort of stuff is, if I have to do an interview and that's the sort of style of thing, I can see it as a useful tool. For me, though, I'm more interested in spending the spare time that I have available to program, to probably program a project that I want to try and complete. I don't find programming fun for programming's sake, really. Like, I enjoy building and designing software. I enjoy building things that I can use to build, like I like architecting systems that I can use later, to build something with, Um, yeah, I find that a lot more interesting. But yeah. So let's go and grab some code. We're going to grab the hprintf code because we did a thing before. Right. So basically, what we want to achieve is, like, we're going to have some buffer, which is going to be a write-only U32. But the basics computing are a bit more fundamental than SE. You can't pick random person off the social engineering. Hey Kappa. Yeah, I'm not sure what are you referring to. You're referring to the leak code thing or some website or something else. Um, right, readback command buffer. So there's our thing, right? So, hmm, you can't pick a random person, obviously, and tell them to write software. Sure, I don't know. I guess it could be a good learning tool, right? But right, discovering performance characteristics of sound approach is definitely a good thing. Just so, so the leak code part is not that. Right. Maybe I'm misunderstanding it because I've not really used it, but for me, it sounded like a way to practice interview questions. But if it's sort of like ranking your approach and gives you tips on, was that the best solution to the problem? Perhaps that's good, right? Because if you have, if you don't understand what is the best way to iterate with this array of things, maybe, or something like that, maybe it is a good idea to pick up some way to sort of like a way to remember what is the best way to do it. So when you actually come to do it in a proper project, rather than thinking about it, or rather than doing the dumb and stupid thing, you already know the way how to tackle that problem best. Yeah, I guess it could be good, but yeah, it's one of those things where that tool wasn't around when I learnt. So for me, it's not really great. But I guess for other people who are learning, it could be a good idea, right? I just don't know. It's just one of those things, right? Um, but yeah, it's not the only way people have to learn, though, right? I think it could help some people, right? Um, so we want to have a readback command buffer. So in the first, so we'll fish out the capacity. GPU readback command buffer capacity index. So you want to figure out how many words you're planning on pushing. See, it would be nice if we can get this all in one expression. If we can do it all in one expression, we can maybe give back an integer, and if that integer is a certain value, maybe like a special value, we can then choose to avoid actually pushing the arguments. Maybe. We'll see. So the args count plus 2, right? Right. So you want to do some atomic add on cursor index. Yep. So you're trying to add this number basically. This gives you back an index. Now, if the index goes over the capacity, it's a problem. Um, hmm. So, like, effectively, we want to have, let's just imagine a command that we're going to make. Let's say print U32. Imagine it just prints out U32 when it gets to the other end. this is what we'll try and get working, and to sort of test out whatever this lower level thing is that helps us at the higher level build these commands that we can push back. Maybe there's, I don't know, just ways of passing commands back, right? So all we would need is a valley. Now, this is going to be calling this push thing. So ideally, you know, you want to be able to say like, well, there'll be some form of like imagine, let's just say, you know, let's say define GPU command type print U32, right? Let's just put that as 0. So basically you'll throw that out in there, and you know, maybe you have one arg. Now so we need a way to make this like really easy. We could pass the arguments into here, right? So you could say, you know, you specify 1, and then you could do variable arguments, and then we could do some form of like special like macro hacky thing to sort of like actually poke them in the right place if it is passed. But then I guess that means if we were to take variable arguments into here, maybe that'd be harder to implement, right? So perhaps super macro hacks, here we go. Command begin, okay. Command valley, this is so hacky, but it's so amazing. All right. Here we go. So we'll have a begin. Right, the begin is going to open up some scope. You'll define some stuff like this here. So we'll get the capacity, buffer capacity, or command buffer capacity. You'll push on a number of words. You'll get back your command arg index. So this thing will just increment every time we call that macro. So then we'll open up an if statement to say, hey, if this plus right, U32, this guy, U32, that guy. Did the music stop? No, it's still going. All right, so if that's less than the capacity, wait, should it be less than or equal? Yeah. Index plus account, it means it's less than or equal, right? Interesting. I think we got something a little bit wrong in... I think it's that, right? Third party. Let's fix that. Excellent. So what we want to do is say, right, if we can write, and then we just leave it there, we don't do anything, right? Then we have another one which is end. Okay, this will end, so we'll put an else there, and then we'll say subtract it. Okay, and then so we'll see if we can store something else in there, I guess, something like that. Okay. And then we'll have another one called value, which basically can be used to put the value in, or the arg maybe. Let's do arg, better. So this will just be used in the middle of the if statement, and we just fill in what we want. So this is essentially just going to say underscore b arg index equals whatever value is, right? And then we are going to increment this by 1. Okay. Sweet. So that right there is how our custom command stuff is going to work. When we want to define our own custom command, we're going to define it like this, and we'll just have a whole bunch of them. Yeah, I think that can work well. Pretty good. So we want to copy this for debug as well. But I guess we can test this out. Let's copy this for debug. So this is debug, command buffer. It all basically stays the same. Excellent. Amazing. Right. So now I think we've done all the high level stuff now. So now we just want to get the low level Vulkan side in. So okay. Here we go. So we've added, so in our sort of like shared code, we've added these 2 new resources, okay? One more high level thing. Oh no, no more. It's automatically solved, that's good. So in the Vulkan side of things, we need to probably start a frame start. We need to just look where all of the hprintf stuff is in here and just basically copy it and do it for the other 2 functions, right? So this one, it says it creates the hprintf buffer. So we need to do it, like we're just going to copy this whole thing, right? Makes it easier. Excellent. So were they in some sort of order? Do I remember? Whatever. The order's kind of messed. It's fine. So, right. You know what? Maybe we can correct the order. Let's just do this. So read back command buffer. So we're just gonna create. So we've got to go into the source GPU Vulkan internal. We've got to add 2 new arrays here. We've got to add like read back command buffer and then read back debug command buffer. Okay, that's all we need to do that. So what we're looking at doing is we just need it as a storage buffer. Yup. And then it's going to be one of those readback buffers. That's good. So everything that says hprintf in here needs to get changed. So this is readback command cap. This is readback command. Readback command buffer cap. Excellent. So same thing for this one. This is readback debug command buffer. Look for this hprintf thing. So readback command, debug command, right? Place all those here just to make a buffer. And then we just need to replace this one with readback. Okay, excellent. So why? Oh, there's a mapped memories thing. We missed that one in the high level. Let's sort out. No. Huh, we did do that. Yeah, they need to be... Right, so these are readback buffers index dot mapped memory. And then we need to cast it into a U, into a void, star. So I'll copy that one and put it up here and just remove the debug bit, right? So that will be the creation of the readback command buffer and the readback debug command buffer. So we just want to get this readback one here and move it up because it's kind of in that order in every other place of the code. So we'll just repeat that order, right? So we're just putting it at the top of these readbacks. Hey there, Ransel. How you doing? How's things been? Excellent. So now we've created the buffers. We've now got to find wherever the hprintf buffer is used and just put the correct sync code in and all of that. So hprintf, let's take a look around. All right. So this is when we start the frame. So the whole idea is when we start the frame, it's in frame start, okay? So what we need to do is we need to invalidate the maps memory ranges so that the CPU writes are visible CPU side, because the CPU has its own cache and we could have read from that readback buffer and it could be in the L1, L2, L3 cache. And what this invalidate maps memory ranges does is it says, right, the GPU has written to this region in memory, basically invalidate the cache, the cache lines that are in the L1 and L2, L3 cache, because they're different to what they are in main memory now. So we just need to do that. So we're just gonna get these. So we'll do readback command buffer. We'll do VK whole size because we don't know the actual size that's written until we actually look at the memory. So we just have to invalidate the whole thing. Command debug command buffer. Okay. So they're invalidated now. What's the next thing we need to do? The next thing we need to do is make sure we set the descriptors up. So just get these at the ready. Just had a 3-hour rehearsal for Midsummer Festival tomorrow. Awesome. How'd it go? What are pointers, eh? Hmm. But yeah, programming is a lot of work to learn. It's definitely not made easy with the current way it's being taught, right? But yeah, it takes a lot of doing your own thing and finding out what is true and what is not true. That's quite a lot of it. Um, yeah. Awesome. Uh, right. Command buffer resource. Excellent. So this is command. Okay. Copy paste this one, and then command buffer is debug command buffer. Bam. Excellent. So now we store the correct buffer in there. I don't know if we actually used that or not, but anyway, we've done it. So now we just need to do the same thing here. So this one updates the descriptors in memory. So when we do the descriptor updates and update the shader descriptors for these buffers, it will set the right ones. These are all built in, remember. So we update the descriptors for the buffers, and we call this update with template with all of these, the memory for all of those, and this updates all the shader descriptors. Voila. Cool. Right, search for more hprintf stuff. Nearly there. So now we're at, wait, where are we at? The sync code. Right, so this is still in frame start. What we're basically saying is, hey, our readback buffer used to be, it was just being read from the host, but now, like at the start of the frame on the GPU, we want to make sure it gets, we want to like put a barrier there to say that it's now going to get used as being in compute shader write. I don't know if we actually need these, to be honest. Maybe we don't need these. Because there's no way it knows when it's done or not. But maybe it can. Yeah, I don't know. I don't think these are actually needed, thing about it. But yeah. Anyway, because I put these in after the fact and it was still running just fine, but maybe some hardware does. I don't know. I think it might be more correct doing this. But anyway, so we need to say readback command buffers, readback debug command buffer. So now I got those all in there. That's good. So where's the next one? So this is at frame submit. It's the other end of it. And when we're finished submitting, I think these ones might be needed. I don't know. I don't think so, actually. So this does it the other way. They're saying, hey, they were just being used by compute shaders. Now the host is going to read from them. So they're just being used in the compute shader for writing. Now the host is going to be reading from them, right? So just going to be copying those and pasting those. Yeah, it's funny. Yeah, it's funny like trying to understand pointers. It's like until you understand it, it feels so weird. Or it feels so like difficult to understand basically, doesn't it? But it's a very simple thing. It's a bit like when someone asks as well, what is a pointer to a pointer? It's like it's a pointer to a point. That's what it is. Yeah. I remember someone asking that before. It's funny. But yeah. Right. So I think that's it. I think we've got our command buffer ready. Should we give it a go? Right. Does the game still run? Summon doesn't work. So let's fix these errors. Then we'll plug it all in. Give it a go. So what is this? Memory mapped, but we got a null handle. Fantastic. So that is at 9:14. I put a debug in there like a twat. Because I copy and pasted it from the other way. Alright, let's fix that. Awesome. So the old thing is still running, but we've not tested out this new thing. So what is this new thing? So we're going to be going into our shaders again, and we're gonna try and print something else, right? So we've got this new command that we've made, but it's in our own custom command buffer. So it's this new GPU. Remember, we've got this sort of like GPU readback command, and then it's called like print U32. So it's just a test one. It's just for testing. It's not meant to be for anything. Like we're not going to be using this. Obviously, we've got a whole printf type of thing, but we just want to make sure that these things actually work. So let's give it a go. So we just want to put a value in there. So let's do 1, 2, 3. Okay, 1, 2, 3 is going to go in, and it's going to print it out on every single pixel. Pretty crazy. You know, we could print out maybe the coordinate, the x coordinate, maybe. I don't know, whatever. Let's just do 1 to 3. So in our gfx.c, we've made a new super lovely iterator, right? So this one is, we called it like a readback command entry, right? Now, from what I remember, it wasn't, yeah, so it's not pointer to that. So we get back, we're actually writing to this specific pointer. So the API is a little bit different, which is a bit annoying, actually, thinking about it. But anyway. Yeah, that's actually really annoying because the API is different to this one. Okay, I think we'll fix it in a bit. Let's just try this. So command read. So we're gonna get back right, single argument, that's right. So it's got a few things in here, right? It's got a type, an args count, and the arguments pointer. So here's how it's going to work. We're going to put some assertions down just to make sure it's all good. Entry dot type equal to 0. We're then going to say entry args count. So the args count that it would have stored in there. Wait, did we store the args count in there? I don't know if we did we? We should take a look. I think we're meant to store... Wait, where is it? Start... Oh no, it's called... Right. So we didn't actually store anything related to the type, the command type, or the... Oh, we didn't do that, did we? Interesting. All right, sort that out. So how are we gonna do this? So we want to say B. So if we were successful, we want to say B this plus 0. I just like doing plus 0. Equal command type. Then I want to say plus 1 equal args count. Then we want to actually increment this by plus 2. Okay, so now I want to copy these and place them in this one as well, because remember we've got a debug one and we also have a non-debug one as well. Unique pointer, what's unique pointer? We don't have a unique pointer, what are you talking about? Where's the unique pointer? Oh, in here. Excuse me. There's a unique pointer. Oh, is this the book that Don was telling us about before? Which is like got so many mistakes. Oh my days. Oh my days. Oh yeah, don't use that book. I remember Don was showing us this book before on one of his streams. Oh my days. The construct of C0, for instance. What? The pointer is a special variable that returns the address of a memory location. Oh my days. Completely wrong. Object value is used in CH. Or refers to just the value of basic type. String copy copies a string constant into the allocated array. Does it mean it's only for copying string constants, right? At the bottom of the heap in a pointer stack is the ultimate object. Okay. Okay. Yeah, this I don't know, did this person get like drunk when they wrote the book and didn't proofread it? Like, how did they release this? I'm still still got 40 plus pages to go. It's gonna cover unions. I'm effed. Great. Like, he's got all of this before he covers unions, just talking about pointers, basically. And then he gets to the union part and is like, oh crap. Oh, it is. That's insane. You see, if I was Don, I would have put that book on a campfire by now. That's what I did before one of my Java books. It was just like, all right, let's just burn this Java book and just keep the fire alive. It was just so pointless, that Java book. Right, so we should. Right, apparently it all compiled. I just pressed the button and it compiled apparently. So yes, arg count equal 1. Then we get the real argument. So we say printf, we found a uint, right? And we're just going to print out entry.args index 0. Voila. So the whole idea is you get to process the args here. You should be able to switch on this type. And yeah, that's the idea. We found a uint 123. Ta-da! There you go. So we can try it with something else, but I think we get the point. Right, it would have asserted by now. So here's our command buffer that we can basically like read back commands with. There is a debug one as well. Should we quickly test that out? Let's get the code at the ready at least so we can debug command. So again, let's do it. Let's do a debug uint, right? So we'll be doing that one. So we'll go all. So let's now go to the shaders. Oh no, here. So let's change this to use the debug command stuff, right? So go to the debug command buffer instead. Apparently it all compiles, and now we get debug uint. Ta-da! Awesome. So that right there is a complete GPU API. It can do all of the things that we want to do. It can make compute shaders, run compute shaders, make buffers, textures. It has an upload buffer to upload directly to a resource, or you can pull it out in a compute shader. You got like 3 different readback buffers, one for printf, one for reading back a particular buffer or a texture into it. We've got 2 readback command buffers, one's debug and one's for the actual game itself. Yeah, it's going to be legendary. So let's just restore the classic printf stuff like that in the logo shader. And there you go, it's back. We just want to also... So I think what I want to do is I want to make this consistent because it's not consistent and it's really annoying. So we just set... We set out a pointer here to some internal memory. And that is the quickest way to do it because it's already there in memory, so just give them a pointer. Now, to maybe get the same API, and since we're only calling it on one thread, why don't we just emulate the same behavior, right? Because to me, it just is annoying if they're inconsistent, right? So I think what we'll do is we'll just have a static local, right? It'd be completely terrible, but you know, it works. And I think that would be a really good idea. So I think what we're going to do is we're going to literally return, so I have a static local, call it entry. So we say static entry, right? And what I'm looking at doing is saying something like that. In 1984, I began to work on Seabreeze, a translator program that accepts basic language source code and converts it into C source code. This explains everything. Okay. I have a C# book laying around here. Excellent. Next time you go to a campfire, just you got keep the fire alive for a long time. It was such a thick Java book I had. It was crazy. I think that the only book I read back about C is the Language D Programmation C23. Basically, the C programming language. Right. Okay, but in French. Right. Nice. Cool. Yeah, I've never read that book, but people say it's good. You know. Yeah. Transpile everything into everything. Oh yeah. Yeah, well, if you're gonna get fast code, I guess compiling to C and then compiling that is probably it's an easy way of doing it. Right, so we can try that. Bear in mind we didn't set the pointer out, right? So it's dref entry out equal address of entry, right? Not the best design, but it keeps the API consistent, and that's what you kind of want when you program, right? You want consistent APIs. Right, so computer says it compiles, so I believe it compiles just fine. But yeah, if it broke, it broke. But there you go. So you'd like switch on the type of command. So you'll say like switch entry type, and you actually put them in there, and you'll handle your things. Ta-da! Command buffers for the CPU to do things. Excellent. So let's get that all checked in. So there's the game running. Awesome. Okay, git commit-a, add support for readback command buffers for the CPU from the GPU. Okay, excellent. So I'm just going to go ahead and push that up to the repo. So this is day 9, isn't it? So we want to do a super lovely we'll do this eval thing. This is still broken on my machine. I don't know, it works on GitHub but not GitLab. So yeah, we've got to do the GitLab dance. So then I want to do a git push. Then I want to do a git tag. Day-9. And then git push dash or origin tags. Right? And I wrote tags because I wrote the word I keep writing args all the time, so it's just muscle memory. Right, then I'm going to do a git log just to check. Right, we've got them all there. Excellent. So I think this is not working on Windows because I need to get the latest HCC and put it in there. But yeah, so maybe I should fix that. I should really fix that like when I'm off stream. But yeah, so let's quickly go over to HCC and get those changes up. What is this change? Again. Right, so we've updated the hprintf. So we have so we've basically like we've made it make resource constants work. Excellent. push this up to the repo. Okay, so that's all on GitHub now. Excellent. Oh yeah. So we need to get that compiling on Windows, but I'm not on Windows at the moment. Okay. So yeah. All right. So if you want to check out the compiler, so we still have like a whole hour to do stuff, but I just want to quickly show that if you want to get access to the compiler and use C as a shaded programming language, the link is there. What else? Yeah, if you want to get access to the code, so if you support me on Twitch via subscription, so you can get that free through Amazon Prime if you have that. Or if you support through Ko-Fi, that's kind of the best way to support if you want to send me more money. But yeah, if you do that as a sort of thank you, you get access to the source code for this whole game here, and you can use it to sort of like learn some things from and use in your own projects, and just see what we do. But yes, we try to keep the code base as simple as possible, right? Because we're just trying to make a code base specific for a game. So the design is designed to be as simple as we can, but still do some advanced low-level things, right? And talk directly to the operating system. Because with these new Vulkan APIs, you can really build something complicated, and that's what we want to try and avoid. But yeah, check out the link there if you want to see more information about that. Right, so we need to figure out what we want to do next. Oh, we could read over this swap chain stuff, actually. This could be an interesting thing, because this got linked by Raymarch last stream, and someone also linked it in the Discord as well. So I think maybe we should spend the time and have a look at this, really. Yeah, I think that's a good idea. Okay. Keep up with the chat. Only that laying maps to see well. It's kind of like the Grohl VM people. Didn't they do a similar thing where they claim native speed because they transpile to low? Right, I see. You found the exact... Oh, excellent. Let's take a look at this one. Wait. Oh, there's a blog post. I'm taking a break from debugging books to about what was this? Calamicious shit show of textbook reading. Mastering C pointers, tools for it. Okay. Learn of the book through Brian Cunningham himself, where he refers to the book as probably the worst C program textbook ever written. He doesn't name it, but with some help, I was able to track down the obliquely. Ah, I see. So he referenced it in a talk, and then someone helped track the book down. Interesting. Oh my days. Yeah, so this... Yeah, I'm not sure I'm going to read all this, but like... But yeah, so let's try and understand what this does at least. So you got an array of chars, right? You're storing some string at a pointer into there, but the string is set to null. Well, it's not set to null, it's uninitialized, right? Great. String len into y, and then you say initialize x to, right? So it starts at there, then t is uninitialized. Great. What is this? Oh, this is old school C, isn't it? S and T get passed in. I see. So they're not uninitialized. Right. Gotcha. So, right. So you pass in a string. Right. Then T is, right, a pointer within. Right. So you iterate over T and you just, yeah. Honestly, when people write C code like this, it's just so, like, it's so weird to understand. Like naming your variables at like X, Y, R, and S is not very handy. Like giving a bit more of a lengthy name, and also using indices when you iterate over your things. Like I know why they were probably doing it this way, because the compilers didn't optimize, so it was a good way to sort of like only use like the minimal number of like, yeah, so the code's more optimized, right? You don't have to keep indexing into like doing an add to the same. You could just increment a variable that's in a register or something instead of indexing it all the time. But yeah, it's just a lot harder to read and understand. Yeah, also you're returning R as well. Yeah, you're returning R. Mm. That's probably the best attribute of this function. Would you use indices in your break condition? Would you use indices if break condition was not based on? If your break condition was not based on an index? I'm not sure what you mean. Like this one, it's still based on an index. You index it, right? I'm not sure what you mean exactly. Like, basically, an index is a pointer, right? It's a relative pointer. You just combine it with a point. Like, if your break condition is a pointer, you can still use an index because your index is a relative pointer from a base pointer, right? It's all it is. Yeah, I don't know. It's really easy to write horrible C code that's very condensed, you know. And this has also got, yeah, it's just riddled with bugs. It's too simple. Yeah, like, uh, yeah, whenever you're doing stuff with strings, you probably want to take like the capacity, like, especially when you're taking something and writing out into something else. Like, if you're writing out into some other memory location, you always want to accompany that with some form of capacity of the range of memory that you're writing to, so it can be safe. Um, yeah, so many problems. Right, let's investigate some C++ code from the Kronos group. Kronos, like Kronos, just they got the C API for Vulkan, which is it's good enough. It's good enough, but everything else that they do, they just make love. Wait a minute, give me a minute. They just make love to C++. Just look at all this stuff. It's all code generated, right? But still, it's pure crazy. So they got like all of. So you got the Vulkan HPP. First of all, let's include 16,000 lines of code because the Vulkan core header is simply not good enough, and we need this thing. So at the bottom, you see they have this like loader, this dynamic loader, and what's the first thing that we did? See here, it loads every single function in the Vulkan. Well, is it every single one? It doesn't look like it. But it loads all the function pointers for them, right? so it can be faster or whatever. But yeah, look all this code I'm just scrolling through. It just keeps going. All these function pointers. But guess what? We did our own version of that in like literally the first day we did after we got the initial Vulkan set up, we cleaned up and went and did our own. Like, we just did it with X macros, and just be nice and clean. We can follow this reference around and see exactly where it's used. And these are all the functions that we use in our Vulkan setup, and they will just get loaded. So we didn't need to include 16,000 lines of code. They've also implement like templates. It's just full on crazy source. So they really love their CPPs. So they implement like destructors as well on some of their things, I think, and so they just wrap every function because they want to. I don't know. So they've got more things because 160,000 lines isn't good enough. Let's keep going. They've got, wait a minute. They've got handles in some form of header, which again is another 15,000 lines of code. Good luck understanding any of this stuff. It's like, I don't know how this is meant to make you more productive as a programmer at all. But anyway, Vulkan loves their CPPs, and it's really crazy. So anything that Vulkan writes is in C++, uses std unique pointer, std unique putter, that's the way they say it. Std vector, std everything, right? So I'm hoping this isn't hard to read, because they typically like to make it super hard to read. So yeah, this is meant to be the way. So let's read the README first. This is meant to be the way that you're meant to do proper swap chain recreation, because it doesn't really work well across platforms. Like, basically, to get proper resizing to work, I've had to, if I do this enough, sometimes it breaks, depending on the platform. Like, if you use an X11, it breaks. And I think I managed to get it to work with my current implementation that I have. But I remember fiddling around with it, and if you do it enough, it just doesn't like it. So, this is all uninitialized memory because we simply just don't write to it. But yeah, I think we managed to fix it, and that's because I had to destroy a semaphore or something like this. And people were saying to me, I don't have to destroy semaphores, but I remember having to do that because... so we're going to reach through this and figure out, maybe try and figure out what's going on and then go through the source code and just see what is the way of doing it compared to our way of doing it. It even takes apart more of these examples. Interesting. Let's take a quick browse. I wouldn't call increment and pointer indexing, but I get what you mean. I know both are semantically the same. Oh yeah, index. Yeah, index, and then you array the pointer. Yeah, it's funny that I didn't believe that existed when I tried it. It's just it's funny though. How confident that your resizing code is correct? The thing is, I don't know. I know that it is good enough on Windows and good enough on Linux, but I don't know about the other platforms I've not tested it on. And I'm not sure if it is incorrect, what are the problems with it? But it'll be interesting to see what is the correct way and why that is, right? Good enough means that I've tested resizing the crap out of it and it seems fine. But we get to see what it is. Oh, so she breaks down all these samples. Crazy. No, it is. Right, we're sticking on track with the swap chain stuff though. But yeah, I didn't know about swap chain maintenance 1 though, so it'd be good to know what this is. So let's take a look at this. And this, I guess, got made core. Did it get made core though? Where's the promoted to core? There's no promoted to core. So this is literally an extension, which is not a good sign. And it's ext and not KHR, meaning it's probably not always supported. So let's go to device. Let's quickly go to GPU extension list. See how many people actually support this. Only 2% support it. So this already seems like another Kronos thing where they're like, look at this awesome extension. It's amazing. And then like no one supports it. Like that's literally Kronos. Check all their blogs, and you'll see there's one called like buffer device. Wait, no. Buffer, where is it? Descriptor buffers. Descriptor buffer, here you go. They made a blog literally November last year. This is the new amazing extension. 7% support. Well done. They've done another one with pipeline, where they get rid of pipelines. And I know they have an emulation layer for that, but they did the same thing and it's got no support. It's called like shader. I forgot what it's called now, but it's where it allows you to set all of the pipeline state dynamically. I forgot what it is. Yeah, shader object thing, that's it. Shader object, that's it. 2%. 2.3% of actual devices support it. Bearing in mind, this is probably including loads of very old Vulkan 1.0 devices, these numbers, right? But still, there's it's like, it'd be good to maybe have a way to query, hey, any Vulkan 1.3 devices or something like this and get different numbers, but still, this is extremely low. Anyways, continue to read. Shame, because I use it. The thing is, you can use it, and you can use shader object, that's fine, because Vulkan have a layer which basically implements it using pipelines, but like it implements it using pipelines underneath and caches the pipelines. But again, you can just write that pipeline caching code yourself, and all it does is save you from writing that code. And it's a very generalized version, so it's more complicated than it has to be. So it has pros and cons. But yeah, you still, like, even though they say if you use shader object, you will avoid the pipeline recompile things. It's like, well, you won't if the platform doesn't actually support it because you use the layer. So, but anyway, Kronos and their silliness. So let's read this thing and see what this says. Yeah, they have a layer. It's just caching pipelines. That's all it does. It does what any graphics API does. You have dynamic state that you want to change. And if you haven't got a pipeline compiled, you compile a pipeline. Like, it's just how they all work. But typically, if you're writing an application, you want to know your pipelines ahead of time, and you compile them when you boot up the program in the background, right? Yeah, they offer an API for something people complain about through the way you take it both sides. Not really, because pipelines aren't really a problem for like a regular person. Like, pipelines are a problem for big AAA engines. That's what they're a problem for. They're a problem for all of these massive, like, AAA engines like Unreal are always compiling shaders because they have these big like material graphs that they dynamically produce shader code. and have all these different permutations, and they don't know the permutation until they're actually playing the game, and then they compile it right when they need to render it. So by not having pipelines, it means they get around that. But the problem for an end user of the problem of the end user having to use pipelines isn't a problem at all. Like, the Vulkan API is complicated in many other ways. Pipelines are not the problem. Okay, a sample that implements best practices in handling present resources and swap chain creation. For example, due to window resizing or present mode changes. Okay. Before swap chain maintenance once, there was no straightforward way to telling whether a semaphore associated with a present operation can be recycled or when the retired swap chain can be destroyed. Both operations depend on knowing when the presentation engine has acquired a reference to the resources as part of the present job, which there's no indicator. So this is the problem I was running into with the semaphore, is sometimes the semaphore is signaled and sometimes it's not signaled, and then you end up having a problem where it's, at least this is what I think it is, right? In this sample, the workaround implemented where a fence is signaled for a class is used to determine when the previous present job involving the same image index has completed. This is often much later than the point where the present resources can be freed. Right. So you kind of want to wait until the presentation engine is done with it. So I could be destroying it still while it's still being presented or something. Right, let's have a think about this. Because of driver limitations. Is pipeline caching required because you can't create all the 1,000 pipelines before? So the problem is compiling a pipeline can take milliseconds. It takes many milliseconds, like maybe 32 milliseconds or something like that. And that's more than a frame. So you have to compile it on another thread. So if you have thousands of pipelines, see, I'm not sure what is the maximum number of pipelines you can compile. But yeah, it does take, it depends how long it takes, right? Because they don't have thousands. They have probably like, well, yeah, they probably have like maybe 100,000 different permutations, maybe more. Maybe they can have 1,000,000 different permutations with just the way things are. They write very, and it's impossible to compile all of those ahead of time. And I don't know how, well, the limit is there, but yeah, like the idea is it's probably better if your game knows all the configurations, even if there is like 100 or maybe 1,000 of them. That's fine, you can pre-compile those bits. When you start getting into this very dynamic set of them, it's yeah. Right. Okay, so in this sample, a workaround is implemented where the fence. Okay, I've already read that bit. Right. So take the following short annotations: PE, presentation engine, ANI, require, Q submit, Q present, wait, signal, reader, present, semaphore, N, swap chain image N, and fence N. So assuming the acquire calls below returns the same index. This is like rocket science here. Let's just decode this, right? I don't know, it seems like too much. The following holds. Fence 2 is signaled. PE has handed the image to the application. P no longer presents the image. The first P operation is finished. P is done waiting on SE2. Right, so a couple of presents. Presentation engine, GPU, R is render, right? So you got your acquire that happens, you got your acquire that happens, right? And so what it's saying is there's a fence. Well, I went to switch to relax because I have a bug with the swap chain recreation for real. Oh, crazy. Yeah, yeah. I'm just trying to figure out like what they're saying is the correct way of doing it. It's weird. Oh. Wait signal. So it's saying presentation engine is done waiting on S2. Signal 4. Semaphore 4. Wait for semaphore 4. Right, yeah. So you submit your work to the GPU. You wait for S3 here in this case to be signaled from the... No. Oh yeah, that's kind of correct. Right. So before you can write to the image, you wait for the semaphore from the acquire next swap chain image. Then you signal. Oh, I can't believe people wrote this. Okay. Then you signal the semaphore S4, and your queue_present waits for this one to be signaled, and then it can present when it wants. Okay. Right. So what it's saying here is, assuming both below returns the same index. So you're saying right, so you're rendering present returns the same index, render present. So I guess the things that you present get copied, or does a copy happen here then? Because like if you can write to the same index, then is that a bit, you're not writing directly to the back buffer then, because it's getting displayed, right? So yeah, okay. Anyway, let's just read on. So at this point you can destroy or recycle S2, right, being signal 2. To implement this, a history of the present operations is maintained. So semaphore 2. Right, am I reusing the same semaphore? I'm just reusing the same semaphore. But whereas they're making a new semaphore for every... Wait, no. Yeah, I'm just reusing my semaphores. Yeah. Which ways for semaphore? Huh. Because the way mine works is we have swap chain. So we've got an image ready semaphore and a present semaphore. So when we acquire, this one will get signaled when it's ready to be rendered to, and then this one is what gets signaled at the end of our rendering, so then we can actually present to the display. So hey there, Leishko. Thank you so much for the sub. Appreciate it. How's it going? I get a validation error for the frame buffer for some reason for all swap chain images. How many frame buffers have you got? Have you got one frame buffer for all of your swap chain, or have you got one for each swap chain image? But yeah. So we reuse the same semaphore. So for this signal semaphore S1 and S3 here, this is the same one in our one. And no, I think that's fine. I haven't had any problems with that. To implement this, a history of present operations is maintained, which includes the weight semaphore used with that presentation associated with each entry point operation. Present operation is a fence that is used to determine when that semaphore can be destroyed. Okay, so there's a fence that says, hey, when it can be destroyed, and F1 gets signal when the present is done. So technically, right, so we might have to, because technically the present, so, right, so technically we can't reuse the same semaphore because the fence tells us when it can be, when the presentation engine is done with, well, right, let's look at it, right? So VK acquire. When you start game dev, did you know math or learn it on the go? So obviously I did standard like school maths, but I just used it as a way to learn more things, right? More maths. Just learn it as you go. So fence is, right, so look at this thing called fence. So, or fence to signal, right? Okay. Classic Vulkan documentation, they'll just tell you nothing. But I guess in the actual spec, it might tell you something more. So if you go to the Vulkan spec, you kind of want the chunked version. Is this the chunked one? No. So you look for chunked because it's not the default for some reason. Vulkan. So you go for the chunked one. Chunked one means it's not a single HTML page, which means you can search for it and just get the chunk that you want. And it's actually a lot easier to find it just loads it right away, right? Anyway, so if you read this might tell you, right? So there's a fence. Okay, when successful, acquires the next presentation image, application use, sets the pnext, blah, 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 may not finish, presentation engine may not have finished reading the image at the time it is acquired. So the application must use a semaphore or fence to ensure that the image layout and contents have not been modified until the presentation engine reads have completed. Once acquired next image successfully acquires an image, the semaphore is signaled, yeah, and the fence is signaled and the fence signal operation. So no, this is not what I was reading. This is different. So the fence and the semaphore are signaled, right? That's what I thought initially, right? Has not successfully acquired an image. Semaphore, the fence. Okay. Okay, so let's go back to reading whatever the Vulkan thing was saying. So at this point you can choose to recycle S2. So S2 meaning the one that was used. So after all of this, F2, this one, is signaled. The presentation engine has handed the image to the application. Yep. Presentation engine no longer presents the image. The first present operation is finished. So it's talking about the stuff before. So when these two are signaled, semaphore and fence, is saying the previous present is finished with. Meaning is done waiting on S2. So you can destroy that semaphore. So we don't want to destroy those semaphores. We want to recycle it. Right? Okay. But let's see what it's saying. So right, so if we queue up a command buffer and we put that signaled semaphore in there, maybe it's not good. Yeah, maybe it does need a few of those things. Awesome, that's cool. Yeah, C++ is a little bit much, right? But yeah. A class of frame sync. Right, but yeah. So what you want to do is you want to have like a frame buffer per swap chain image, right? And you switch between the frame buffers every frame, depending on what is your swap chain index that you get back from the VK acquire next image, right? Okay, so I think I'm understanding what I'm doing wrong, but it hasn't shown any actual problems on the AMD drivers that I've tested on Linux and Windows. Okay, but okay, good to know. So after each present call, the present history is inspected. Any present operation whose fence was signaled is cleaned up. Wait a minute. Since the fence is not actually known to present time, Q present, the present operation is kept in history without associated fence. Once the acquire next swap chain image returns the same index, the fence given to. Okay, whatever. Right, so I understand what this is saying and where we're going wrong in R1, right, according to this. So let's look at this swap chain recreation. When recreating a swap chain image, all images are eventually freed and the new ones are created, possibly with a different count and present mode. For the old swap chain image, we can no longer rely on any future acquire next swap chain image to know when the previous presentation semaphore can be destroyed. For an old swap chain, we can no longer rely on any future requirements to know when the can be destroyed, as we won't be able to do any more acquisitions from the old swap chain. Similarly, we cannot know when the old swap chain itself can be destroyed. Great. Yeah, because you have to know, you know it from the acquire. Maybe. Right, let's read into this. The issue is resolved by deferring the destruction of the old swap chain and its remaining present semaphores to the time when the semaphore, according to the first present of the new swap chain, can be destroyed. This is rocket science. Because they basically, oh my days. It's funny because they designed the API. Oh. So the API is literally buggered from the get-go. They designed the API when you create the swap chain to take in the old swap chain here. And what they're saying is you don't know when, like, because this was meant to like recycle the old swap chain, but I guess they don't really do that anymore. The non-retired swap chain to surface. So you're meant to wait until the swap chain is done. Oh my days. Who? This is buggered. Right. I keep the semaphores and fences for each image. Yeah, it's pretty maddening to be honest. Oh. Yeah, I just need to double buffer my semaphores and I guess I need to use fences now. Well, no, I don't need to use fences. Yeah, I don't need to use the fences. You never need to use fences, just the semaphore. Oh, talking about swap chains, the Vulkan tutorials that I've seen so far use a depth image for all swap chain images. Isn't that bad? Um, no, like, you know, if you're rendering something in 3D or even in 2D, you might want a depth image. Like, it's like having a depth buffer is pretty fine on, you know, like GPUs can handle like tons of images and you know in a frame buffer. It just adds more complication to when you're writing the Vulkan code is all. Um, but yeah, if you want to try and teach someone Vulkan, it's probably not the best thing to do right away. The thing is that you have to do it for resize. Is it? I don't know. My resize works fine without a fence. But yeah, let's keep reading. Let's figure this out. Oh, share the same depth image. Oh, cheers for that very much. Thank you. So share the same image. Yeah. Oh, yeah. I did misread that. Sorry. Yeah. That is not a good idea. Wait. Um, that's fine because the lifetime. Why did I write Vulkan? Yeah, that is completely fine. So long as this is true. Right. So you got a frame that's running on the GPU, and you have the next frame that runs on the GPU, right? This takes swap chain image 1, this takes swap chain image 2. And obviously it takes depth in as well, okay? And depth, okay? So basically, you're writing to swap chain image 1 and depth in here, right? So long as you have a semaphore, right, where this signals the semaphore and then this waits, and this one here waits on this semaphore. So as long as this one completes, and then this one only starts when this one is completed, then sharing the depth image is okay, because you will never have two commands running at the same time which read and write to the same depth buffer, right? And that's it. but it entirely depends. It all depends on that basically. Is there two things that can possibly write to the same resource at the same time? But yeah, I don't think it's a problem. Yeah. So things solely live on the GPU. Hmm. Yeah, so if things solely live on the GPU, you can do that. But if things are um yeah, but you know, if you have temporary resources, you have to do a different depth image. So maybe you're anyway, this is more complicated, Vulkan. Maybe your depth image is temporarily allocated into, and you have anyway. I'll ignore that one. Couldn't you otherwise start rendering the next frame already, but when you have to wait? Um, well, the idea, um, yeah, like there will be, like, there's no perfect thing where way of rendering where you wouldn't have to wait in some way. You always have to put down a pipeline barrier. You always have to at least put down these semaphore signals, right? And you have to wait for something. But the idea is when you're writing your rendering code, you want to minimize that. But typically, yeah, you can basically reorganize things to where um, maybe jump scare. What's the jump scare? What? Oh, is there an audit? Sorry about that. Apologies. Did I knock the cable? How's it? Oh shoot. Sorry about that. Ah. Right, that fixed it. Thank you. Yeah, so basically like, you know, you might like you could theoretically like you might have one command buffer and when it's finished it's finished writing to the swap chain to the swap chain image, right? And it's ready to be presented here. But you could theoretically have bridge another command buffer here, which maybe runs actually alongside this one, where like, and this one gets signaled when it's done, and this one gets signaled when it's done, and maybe like, or no, maybe this gets signaled earlier, in some other command buffer or whatever. But you can have some code, you can have some other stuff that prepares the next frame or something, if you know what I mean. But yeah, there's different ways you can architect the renderer. It's all quite complicated. Maybe a bit hard to explain. But yeah. Like the problem if you don't put those the waiting for the previous frame to finish rendering is that you have to double buffer or triple buffer your resources, thus increasing the amount of memory you're using on the GPU, which is not a good thing. Like you want to, yeah, pretty much. Like give all of the control. Right, so as we read here, for the old swap chain, we no longer can rely on any future acquire next image to know whether previous presentation semaphores can be destroyed, as there won't be any kind of acquisitions from the old swap chain. Similarly, we cannot know when the old swap chain itself can be destroyed. This issue can be resolved by deferring the destruction of the old swap chain and its remaining present semaphores to when the corresponding when the semaphore corresponding to the first new swap chain can be destroyed, because once the first present of the semaphore and of the new swap chain because once the first present semaphore of the swap chain can be destroyed, the second or the first present operation of the new swap chain is done, which means the old swap chain is no longer being presented. Okay. I get what it's saying, right? Say if this is the old swap chain, this is the old swap chain, this is the new swap chain. It's saying, well, when this one's presented, then obviously the old one has not been presented anymore. Now the swap chain may be recreated without a second acquire. This means that the swap chain could be recreated while there are pending old swap chains to be destroyed. The destruction of old swap chains must be deferred for when the first queue present of the new swap chain has been processed. If the application resizes the window consistently at a high rate, we will keep accumulating old swap chains and not free them until it stops. Bummer. Would be recreated while they're on. This means that the swap chain could be recreated when they're. When the first queue present has been presented. So they basically just leave this problem here, and they didn't tell you how to solve it. So let's look at the code. I thought that swap chains are all about so that you can have more overlap and less idle time. So if you have like 3 swap chain images, right? So if you have 3 swap chain images, you render one frame to the first swap chain image. Right, let's grab this. So basically you have 3 swap chain images, right? You render to this one, you complete it. Okay, you put that in, you complete that one. Then, because you've got 3 images, you can then render to the next one. Bear in mind, this one hasn't been displayed to the screen yet because of VSync, right? But you start rendering to this one, right? And then, but this one's at the front of the queue, so by the time, when it becomes time to display it, it will be displayed to the screen. Yeah, you only sit and wait. Yeah, because your command buffers that are chained together don't wait for the present. They wait for you to, they wait for the frame to actually be done rendering, right? So this is the first frame that you render, and you end up rendering to the swap chain image, right? When this is done rendering to the swap chain image, you queue the where is it? Yeah, so this will, when this is done rendering, it will say, hey, we can start rendering the next frame. It's not going to wait for the present here. and wait for it to be presented to the screen, it's going to allow you to render the next frame. But you're saying in order to present this image, we're going to queue a present, right? We're going to signal the semaphore to queue and present this image. But maybe before the present is finished, this render for the next frame finishes, right? And we queue another present. And depending on what our present mode is, if we queue to present and we're using mailbox, for instance, that's first in, last in, first out, right? It means that the newest image gets displayed. So this one will just get discarded, and then this one will actually get presented, right? You see what I'm saying? That's basically it. You're not waiting for the present. You're queuing it to be ready, right? Yeah. Right, so let's take a look into the rocket science, which is swap chain creation. You know, 1,000 lines. Let's do it. So basically, let's just look at it from the whole resize thing, right? Because resizing is the bit we want to understand. This is interesting. They got all this now. Look, Microsoft did something to GitHub. I don't know if this is what I like, but anyway, we got. Right, so there's many different resize calls. So if you resize the swap chain, it gets the surface capabilities, then it calls initialize. Initialize. Oh yeah. No. So it gets the new surface capabilities and then calls initialize swap chain, but then gets surface capabilities. Only rebuild swap chain if the dimensions have changed. Right. Okay, fine. Then you get the surface capabilities again, and then if it's equal to the special number, we define one. This should really be min and maxed between the min and max extent. This is technically wrong, this line here, but anyway. Because there is a min and max bound still, and that's defined by min and current extent or whatever it is. Anyway, do triple buffering when possible. Good. What is love, Mr. Henry? What is love? Do triple buffering when possible. This is clamped, min and max. Maybe they do clamp it. Yeah, oh, maybe. No, it's min image count. No. Right. They put the old swap chain in there. Interesting. So they put the old swap chain in there. Okay. Of course, it's a class. So swap chain is part of the this pointer. Okay. Should probably zoom in a bit on this one, right? bit easier for people to read. So, you know, it does this. Technically, it should wait, right? Where's the waiting? I don't see any waiting. So this is saying schedule for destruction. So I don't see any wait, which is interesting because from what I understood is you had to wait when you recreate the swap chain, but maybe you don't because it doesn't actually destroy it. Why did they write such a bad API? Where's Vulkan 2 already? Schedule it for destruction, so just adds it to some array, right? If it's empty, if no presentation is done on the swap chain, destroy it right away. Okay. Place any present operation that is not associated to the fence to the old swap chains. That gets scheduled for destruction when the semaphore of the first image of the next swap chain can be recycled. And did they get it right the first time? No. History to keep. Right, so place any present operation that has not been associated with all swap chains. Let's get scheduled. Oh my days. So it's present information, present history. So you end up setting this cleanup data and pushing all these vectors of right, so then you have these old swap chains. So okay. What does the Vulkan cube look like? So you create this, when does it do a VK create swap chain? Not in here clearly, is that in some? In a VK swap chain. Oh, it's the C++ version, isn't it? Damn it. But yeah, I don't know, this seems like it's very complicated to do it quote unquote properly. Yeah, it's probably something we should probably visit. Like, I don't know if it's worth solving anything yet because right now we don't have any problems. Right, technically it's not correct according to the Kronos spec. But you know, okay, this is because we simply don't write to the swap chain image, so ignore that bit. But yeah, we don't have any crashes. But yeah, it would be interesting to maybe, like, you know, if I actually need to release this thing, it'll probably be good to make it as part of that work there. But yeah, it seems very complicated. Like, I understand where we're going wrong in one respect, but when it comes to recreating the image, it seems like it's got a lot of... No one was reading this recreation part. This seems very complicated, you know? Anyway. It seems like they could have made the API a lot easier, but they chose... But I guess they maybe didn't foresee it going this way, you know? There's a cube.c. We've done a cube.c? Okay, I didn't realize that. Right. Alright. Time for me to shoot. Oh, it's getting quite late. Plus, gotta go and travel into work tomorrow. Right, is this on for us to raid? Thank you so much for coming, Glorissa. Appreciate it. Thank you everyone for coming. So I won't be on Sunday. No Sunday stream. I've got a family thing. But I'll be streaming next Tuesday and next Thursday. So what's happening on those days? We'll be working on custom memory allocation, object pools, dynamic stacks, so like arrays, basically dynamic arrays, stacks, hash table maybe. So we'll be getting those in to the code base. I'm going to bring some in and describe what they are as we go. Man, it's so warm in here. I don't know if you can see. Oh, bloody warm. Right, let's raid this dude. Is he live? Alright. Good night, not so red. How you doing? I'm sorry, Ty Beaver, it just has to be. Okay. Right, thank you for coming. I'll see you all in a future stream. Have a good rest of your week. I'll see you all next Tuesday. Right, catch you later. Bye-bye. I'm gonna grab some milk, exactly. Bye-bye.